In this chapter, you'll become acquainted with the most important sensors and the associated input signals, and you will learn what effects these signals have on engine control. You will learn about the throttle valve control, the air path sensor system, the speed-dependent input signals, and the two most important sensors for injection and ignition optimization. In order to be able to perform all functions relevant to engine management, the control unit depends on input signals which indicate precise load and operating conditions and complete combustion in the cylinder. Basically, the sensor system must record three input variables. The driver's load requirements. This is dependent on the electronic accelerator pedal and the electronic throttle valve. The corresponding elements are colored yellow in the system diagram. The mass, temperature and pressure of the air flowing through the intake pipe. The corresponding sensors are colored blue in the system diagram. The position and speed of the crankshaft and camshaft. The sensors are colored orange in the system diagram. In addition, there are the knock and Lambda sensor systems, which are responsible for controlling the correct ignition times and complete consumption. Please choose an area by clicking on it with the mouse. The engine load, for example idling, partial load or full load operation, is mainly determined by the amount of the air flowing in. Depending on this amount, which is characterized as air mass, the engine control unit calculates the petrol to be injected as well as the timing of the ignition. In modern engine control systems, the air mass is determined by a hot film air mass sensor. This works according to the following principle. There's an electrically heated element, the hot film, in the intake air stream, which is cooled by the flowing air. Basically, the hot film functions as a temperature-dependent resistor. The voltage measured at the hot film is the parameter used to measure the air mass. Because the more the air flows past the hot film, the more it cools off and the greater the voltage becomes. The air temperature is decisive for its volume. The hotter the air is, the more it expands. However, there are then less molecules in each volume unit of air, which means less oxygen for combustion. The engine control system has to take this into consideration and must allow for more air as the temperature of the air increases in the intake pipe. The intake pipe pressure is one of the input signals which the engine control system uses to derive the opening time of the injection valve. The vacuum in the intake pipe is added to the constant valve injection pressure. In this way, more petrol is injected in the same amount of time. The engine control system compensates for this by shortening the injection time and/or the valve opening time. The stronger the vacuum is, or the less the throttle is opened, the shorter the period in which the valve is open. Please determine whether these statements concerning the intake sensor system are correct. Correct. The throttle valve opening angle determines how much air can flow through the intake pipe and how much petrol has to be injected into the cylinder for combustion. In the ME engine control system, the throttle valve is no longer activated mechanically by the driver applying pressure to the accelerator pedal. Instead, the engine control unit evaluates the position of the accelerator pedal electronically, and depending on this position, opens or closes the throttle valve. This function is known as the electronic accelerator pedal, EGAS. The throttle valve actuator also operates as a sensor for the engine control unit. as the electronic control system must constantly monitor whether the throttle valve has assumed the calculated position. The throttle valve actuator also indicates the load conditions, full or partial load, to the engine control system. Together with other input signals, the throttle valve position is also used to determine idling or overrunning of the engine. Please indicate the correct statements concerning throttle valve control. Correct. The engine speed is recorded as one of the main operating condition variables by the crankshaft position sensor. Corresponding to the engine speed, the ignition timing and the injection period and timing are optimized, thus improving the composition of the mixture. The camshaft hall sensor records the position of the camshafts. The camshafts control the inlet and outlet valves of the engine. The exchange of gases, that is the intake and outtake of the mixture, and exhaust gases, also takes place here. Both sensors, the crankshaft position sensor and the camshaft hall sensor, supply the decisive input signals for the timing of both injection and ignition, as both procedures have to be synchronized precisely with the valve position and gas exchange. Please determine whether these statements concerning the crankshaft and camshaft sensor systems are correct. Correct. Two additional sensors are very important for optimum engine running: the knock sensor and the two Lambda probes. The knock sensor records the vibrations that occur on the cylinder in the case of premature ignition or uneven combustion. Depending on the operating conditions and input signal of the knock sensor, the point of ignition is shifted towards the late position. If the knock sensor does not record any further vibrations, the point of ignition is shifted back in increments towards early. The Lambda probes measure the remaining oxygen content in the exhaust gases, which indicates the completeness of combustion. Depending on the operating conditions and input signal of the Lambda probes, the mixture is enriched or made more lean. More detailed information on this sensor system is provided in Part 2 of the study program, the Injection and Ignition System.